going to talk more about parabolas today. We've talked about them before and properties that they have, such as they all have a vertex, which is the highest or lowest point, and they all have a line of symmetry called the axis of symmetry that cuts the graph in half and makes it symmetric. Two things we're going to add today are called the focus and the directrix. Two more parts of parabolas to discuss. A parabola is the shape that is found by finding all points equidistant from the focus and the directrix. Now, focus is just some point that everything in the parabola is going to be centered around, and the directrix is just some line. This will be my directrix. And I want to make a list or a collection of all the points that share the same distance from the focus in the directrix. For example, like if I put this point here, then this space and this distance are the same. And if I picked a point like up here, this distance and this distance are the same. And halfway between these two, this distance is the same. And if I graphed all the points that have the same distance from the focus and the directrix, it's going to look like that. And this isn't a perfect example, but like this distance here is supposed to be matching this distance there. It's actually pretty good. We can look at a better example here on my sketch pad. Here are the directrix that I've made, and here's a focus. There's my focus, there's my directrix. And as this point A moves along, you can see that this distance, which is found here, and this distance, which is found here, stays constant. As I go up here, as I go down here, I'm sorry, these are always the same. They're not constant, they're changing, but they're always the same. And if the focus gets further and further away, the parabola gets flatter. If the focus gets closer to the directrix, it gets more and more narrow until here it's going to flip. And if I change the angle of the directrix, I can change the angle of the parabola as well. All sorts of fun things you can do with these, but we'll not worry about that right now. Right now, we'll just get back to some algebra. So I'm going to find the vertex, the AOS, the focus, and the directrix of this equation, this parabola, and then I'm going to graph it. So I'm going to go split screen. So I'm going to do this problem while looking over at this set of formulas here. These are the equations for parabolas. It's no longer found on this page. You can ignore that. If the y value is being squared, the parabola points sideways. But if the x value is being squared, the parabola points up and down. That's not terribly new. I mean, we graphed parabolas like this all the time, and we knew those pointed up or down if a was positive or negative. In fact, we even graphed these, which is almost the exact same, only this plus k, they've moved over there and made it a minus k with the y. And this a value is no longer a, it's 1 over 4p. And that's the thing that kind of takes the most adjusting to, and we'll get a feel for that. So in this equation over here, the y value is being squared. Excuse me, the y value is being squared. So we have one of these situations where everything will be coming out of this box. Additionally, I know over here that the a value is positive. Now, on our formulas over here, we don't call it a, we call it 1 over 4p. So really, 1 over 12 is the same as 1 over 4p. And I've got to find this p value. Finding p is kind of the most important step here. Everything else kind of comes from there. So if 1 over 12 is the same as 1 over 4p, this coefficient here matches this coefficient here, then my p value must be 3. Because 1 over 4 times 3 is 1 over 12. So my p value is 3, I know that my h value is 1, and my k value is 4. H is always next to x, k is always next to y. So I have h is 1, k is 4, p is 3. Now I can graph everything. I very, very strongly recommend that you take your vertex, the point hk, which in this case is 1, 4, and put that in the middle of your plane. Okay? I don't have an x or a y axis yet. In the middle, I'm just going to call this the point 1, 4, and that's my vertex. Now I'm going to build everything around that. I'm going to put an x and a y axis around that. So here's my y axis. Here's my x axis. And now that's at the point 1, 4. This guarantees I'll have enough space on my plane to graph everything that I need. So there's the vertex at the point 1, 4. We can also find the AOS. We know the line of symmetry is going to be at y equals k, which in this case is y equals 4, because the k value is 4. So there's a line of symmetry at y equals 4. Which is here. That's the line that my parabola is going to be symmetric around. And since the a value is positive, I actually know this parabola is pointing to the right, so it'll look something like this. I'm just not sure exactly how it looks yet, so we have to find where those points are. So we've done this one and this one. Now let's find the focus. Focus is the equation k comma h plus p in this case. Here it's h comma k plus p, but we're doing k comma h plus p. Which is 4 comma 4. That is my focus at 4, 4. The directrix is x equals h minus p. X equals h minus p, and that's a minus there. So the directrix is at x equals h minus p, which is 1 minus 3, which is negative 2. X equals negative 2 is right here. That's my directrix. And these four things, focus, vertex, directrix, AOS, frame the graph, but they don't really actually help me find points. I need to be able to find those things to make this graph, but I want to find more points to put on the parabola. And here's the best trick for doing this. Okay, whatever the distance is from the directrix to the focus, that's a distance of 6. Whatever that length is, from the focus, go up or down 6. And now, so this length here was 6, and this length here was 6. And those are 2 more points in my parabola that I can kind of curve out from. Every point on this parabola has the same distance from the directrix and the focus. Okay, let's go to another example. And all this should be gone, excuse me. I'm going to write the equation of a parabola. Excuse me, these things didn't clear from before. Write the equation of a parabola with that focus and a directrix at x equals 6. Focus at 2, 8, and a directrix at x equals 6. So I'm just going to graph those things. I'll put 2, 8. I would like to put the vertex in the middle, but all I have right now is a focus, so I'll put my focus here at 2, 8. That's my focus. And the directrix is at x equals 6. Well, if that's the point 2, 8, then there's my y-axis. 1, 2, 3, 4, 5, 6, 7, 8. There's my x-axis. There's the point 2, 8. The directrix is the line x equals 6. So 1, 2, 3, 4, 5, 6. This is my directrix. Here's the nice thing about setting up this graph and looking at it. I know that the vertex has to be exactly halfway in between. The vertex is always halfway between the focus and the directrix. So here's my vertex at the point 4, 8. And now I can grab that orange line that I drew before to find some more points on this. This distance here was 4. So I'll go up 4, 1, 2, 3, 4, and put a point, and down 4, 1, 2, 3, 4, and put a point. That's 4, and that's 4. And the parabola is going to go like that. Now, all of that graphing doesn't actually help me find the equation very much. It isn't actually necessary, but I think most of you will find it really, really helpful if you can actually understand, oh, okay, this parabola is pointing left, which means that the a value is negative, which really means that this p value here, we're doing this scenario here. So if the a value is negative, the p value must be negative. And because I took the time to find the vertex, I know that h is 4 and that k is 8. So now I just have to find p. And I know I'm doing this equation here. So I'm doing x minus h equals 1 over 4p y minus k squared. Well, finding p now is actually pretty simple. For example, they told me the directrix was at the line x equals 6. So I can just take my directrix equation, but I know that the directrix was at x equals 6, so it's really 6 equals h minus p. That's a really bad 6. And I know that my h value is 4, and I solve for p. It makes sense that p is negative because we knew p had to be negative, so p is negative 2. Now I can just plug in hk and p, and I get x minus 4 equals 1 over negative 8 y minus 8 squared. And there's the equation of that parabola. Finding p after you find h and k give you or come from your vertex, p can come from your directrix or your focus, whichever one of those things are given. One more example, then we'll be done. I'm just trying to keep this screen here. We're going to find the focus, the vertex, the directrix, the AOS, everything, and graph this. This equation actually looks really similar to the old vertex form we used to see. It's like this plus 4 is just, used to be over here as a minus 4. So I know that h is 2 and that k is negative 4 from this and this. I'm just going to find p. Well, my a value right now is 1 over 8, but it's really 1 over 4p. So it's 1 over 4 times 2. So my p value is 2. So now I have h, k, and p, and I can use those to graph everything. So the center of this graph is going to be at the point negative 2, negative 4. And again, I put that in the middle of the graph, but that's my vertex. The vertex is at negative 2, negative 4. I build my axes around that. I cannot stress how helpful this is. At negative 2, negative 4. Now, what else can I find? The AOS. Because I'm doing x squared, I'm over here now. I'm in this box. So my AOS is line x equals h, and x equals h is really going to be x equals 2. So this is my line of symmetry. That seems off. Negative 2. H is negative 2. Hold on. Yes, h is negative 2. So the vertex, the AOS should be over here. Oh, that's annoying. Because the h value is negative 2. And what else can we find? The focus is at h comma k plus p. So the focus, h comma k plus p, which is negative 2 comma negative 4 plus 2, negative 2, negative 2. There's the focus. So the directrix, I could use the equation, but at this point I know it's going to be the same equidistant away. That was going to be here. Now I'll do my little orange trick. I can get this section here is 4, so I'll go 4 this way and 4 this way. And here's the rest of my graph. Here we go. We found it all. As you do your homework, make sure that you find the AOS, the focus, the vertex, and the directrix. Please label them with their actual equations and make nice, pretty graphs with lots of graph paper. You're going to want lots and lots of space. Thanks for listening. Good luck.